Okay, let's begin with question number 8. All right. So hollow right circular cylinder open at one end is constructed of a thin metal sheet. Aha. All right. So the total external surface area of the cylinder is 192 pi. So hollow means, okay, let's keep this end fixed. This is the block and this is the hollow part. Yeah? So we have a H here all the way from here to here. This is the height of the cylinder. Let's mark that. And of course, we have the radius in between like that. This is a dot R. Okay, the total external area means, this is a bit tricky statement. So total external area is what? What's the formula? So total external is outside. So outside area is 192 pi. So 192 pi means not just there's this curved surface area of the cylinder, which is the 2 pi RH. It's a formula. It's a curved part. And then at the end here, oh, we got one more part, which is the circle, area of a circle. But we don't add 2 pi r square because the front part here is hollow. Please take note of the small trick here. If it's closed, then it will be 2 pi r square. If it is hollow on both sides, it will be just 2 pi RH. So that is the trick, this question, one of the tricks. So as a radius of r and a height of h. So express h in terms of r, and that's what we're doing now. So we just rewrite this, or we can just divide throughout by pi first. Okay, so if we divide throughout by pi, this becomes 2rh plus r square equals to 192. Okay, I'm going to put an indicator. You can just say like divide pi to get this. Okay, so 2 double dot like that. Making the h the subject of the matter. Then we make 192, bring the minus r square, whole thing divided by 2r. Please take note, this is the value of h in terms of r. Okay, that's done. So now we do the volume part, first part here. So the volume of the cylinder has the formula of pi r square h. So let's just substitute. So pi r square, the h part, I'm just going to take from here. Okay, so we're going to substitute here the h. So 192 minus r square over 2, and then close the bracket, please, like that. 2r, sorry, just missed the r there. So we need to calculate it now. There's reductions. So here we can see that the r and r can cancel off. So the pi r outside over 2, 192 minus r square, the whole thing over half like that. Put the 2 in front. So slowly taking shape. So always compare with the given one. So you can see that the r's are inside. That means we need to multiply this back inside. So and therefore we get the answer or proven part as half pi on the outside. Try to copy the exact time. It's how they write. So 192r minus r cubed. So this part is done. Okay, so how we prove that? That's it for the first part. Okay, let's go for the second part, please. So I'm going to clear the screen and go for the second one. So I'm going to write find the value of r for which v has a stationary value. So let's say we do that. So we can straight away use, even if you didn't get exam tip, the first part, you didn't get to prove the first part, let's say something got stuck or what, don't give up. Do the part 2 and 3, assuming the result in part 1. So you may not get the 4 marks, but if you get this remaining part correct, you still can get your 6 marks, 3 plus 3 here. So we can just assume and do. They don't penalize like that. Okay, so let's say we just multiply this out. What is 192 over 2? It becomes 96. So we have 96. 96 pi r. Sorry, very nicely. 96 pi r minus pi over 2 r cubed. So I'm just like writing it like that. Okay, now we do a bit of differentiation. So dv dr will be, we differentiate against respect to r, because given r that can vary, that's the meaning. Yeah. So stationary value, I'll come to that, find the value of r. So we differentiate first, 96 pi, and then this is times 3, right? 3 pi over 2 r square. So being that said now, 3 pi over 2 r square like that. So stationary value means what? Stationary value is when the dy dx, or in this case dv dr, is 0. We have to set dv dr equal to 0, and solve for the value of r respectively. So that means that we put 96 pi minus 3 pi over 2 r square equal to 0. We can immediately eliminate the constant pi and put the 96 here, the r square the other side. So r square is 2 over 3 of 96. Just some calculated things. Okay, let's calculate 96 times 2 over 3, 64. Normally, a nice number that will be a good indicator. So r is 8 because being positive, the square root of 64. So find the value of r. That part is done. That is, yeah, because the radius doesn't have a negative. So this kind of exam boards are very sensitive singular plural. Actually, they're kind of helping student because you can just see the singular plural and realize it's only one answer. Okay, and then the third part. Let's have a look at the third part, please. Find the stationary value and determine whether it's a maximum or a minimum. So when they say find the stationary value, means find the value of v when this r happens. So the value of v when r equals to 8 would be, so it's just back to substitution. Oh, so 192, and r is 8 minus 8 cubed, just substitution. And this is just some calculator work. Let's put it in the calculator. 192 to the bracket first line times 8 like that, minus 8 to the power of 3. Ta-da! You get 1024. Divide by 2. You may want to write this 512 pi just to be more accurate in case. Okay, times, sorry, shift pi. Aha, so it became, let's have a closer look, please. 1608. 1608, yeah. Okay, just put this, doesn't matter decimal place. That one just check with the exam board on that year, whether they're going to penalize for all that. Okay, so those are trivial stuff for me. Okay, anyway, let's determine whether it's a maximum or a minimum. So this part is a little bit interesting because to determine whether it's a maximum or minimum, one of the easiest ways to do a second differential. So that means I'm going to upgrade from here. Can't really upgrade now. Let's think like that. So from here, what we do is we do a second differential on that. So dv square dr square. Let me basically just differentiate it again. Constant part becomes 0. So minus 3 pi over 2, just times the 2 and then bring the r down, like minus 1, like you'll know this. So this becomes 3 pi r. Okay, just straight away, just write 3 pi r. Yes. And then we put the value of r in this to check whether it's positive or negative. So when r equals 2, so we evaluate it. See, there's nice notation. It's good to learn early. It's like sometimes in calculus, it do just dv dr square. It's kind of complicated, write the whole thing again and all that. So if let's put a slice like that and you write r equals to 8. That means you're evaluating this, what do we say? Second differential when r equals to 8. So 3 pi and the value of r is 8. So it becomes 24 pi. You don't even need to calculate. We know this is positive. So if it is positive, the second differential positive means the original function, the function in v, okay, the function in v with respect to r or something, that's why they put something vr like that, is having a minimum value. It's always the opposite. I mean, like positive, minimum, negative here means maximum. Just a shortcut, people talk. There's no real maths meaning to that phrase, because that must be proven rigorously. So the property is, if it's positive, just remember this. That means what I'm trying to say, if the second differential is positive, we have a minimum. Okay, I'm just mentioning this generally. Yeah. So even though in this case, there's no other route for us to evaluate it negative, but just for sake of learning, if you would have gotten a negative, then for the value of r, then that would be a maximum, the highest value, local maximum in that area. Thank you.